This is the 2005 Impacts and Collisions question. Part B, smooth sphere A, which we have here. Mass M moving with speed u in this direction is going to collide with an identical smooth sphere B, moving with speed u as well, both at 45-degree angles. The line of centers and the direction of B before impact is the same, 45 and 45 is what they're telling us here. Coefficient of restitution E, and we're asked to find, in terms of E and U, the speed of each sphere after collision. Okay, let's look at A here. So A, we have U, it's going in a positive direction. So we have U cos alpha in the I direction, as you all know, plus U sine alpha in the J direction. So let's apply this to A and B. So for A, U by the cos of 45, U over root 2 in the I direction. Sine 45 is the same, making this question a little bit easier. U over root 2, or U times 1 over root 2 in the J direction. And for B, in this direction, it's going in a negative positive. So we just have to change our signs. Negative U over root 2 in the I direction, plus U over root 2 in the J direction. It's what's happening with these spheres before impact. Now we know there's no change in the J direction here, so let's apply our Newton's experimental law. Firstly, the principle of conservation of momentum. So let's just write A and B out for what's happening. We have no change in the J, so we're going to have, for A, X in the I direction, we'll call it, plus U over root 2 in the J direction. And for B, we have Y in the I direction, plus U over root 2 in the J. We'll call these V1 and V2 when we're solving it. So, principle of conservation of momentum. mu1, I'll just write the whole thing out. I know you all know it. mu1, if you're doing this video, plus mu2 is equal to mv1 plus mv2. All the m's being the same, we can cancel them. So that should have been a 2 there, a 1 there, realistically. But you know what we're doing here. So m, we're solving, don't forget here, we're solving for the I. So let's focus on the I direction. So before we have these two, so if we divide by m to start, we can say u over root 2, these are going to cancel, minus u over root 2 is equal to v1 plus v2. I'm going to say x is equal to v1, y is equal to v2. If you're used to using v1 and v2, just continue to do that. So we're going to get v1 plus v2 is equal to 0 to begin. This looks like it solves a little bit quicker maybe than we might have thought. Newton's experimental law. V1 minus V2 over U1 minus U2. So this is where we're actually going to add them together. They cancel the first time, so we're going to get U over root 2 minus U over root 2 is equal to minus E. So we've got two of these guys, so we have V1 minus V2 over 2U, two of these guys, so we've 2U over root 2, 2U over root 2, and that will be by the minus E. So just tidy this up, V1 minus V2 is equal to minus 2UE over root 2. You can multiply by root 2 top and bottom to get rid of the third if you want, but I think they cancel pretty quick. So if we bring this one down, v1 plus v2 equal to 0. We get 2v1 is equal to minus 2UE over root 2. And dividing by 2, we get v1 is equal to minus UE over root 2. The 2 will come underneath and cancel with this 2 on top. And if v1 plus v2 is equal to 0, v2 would have to be the opposing side of this, which would be plus ue over root 2. So we have v1 and v2, so to get their speeds, we're after speeds, aren't we, after collision? The speed of each after collision, so let's write down A, we call it this A. We solve for I, so we have minus ue over root 2 in the I direction, and they were 45 degrees, it was u over root 2 in the j's. That's the velocity of A after, it's the velocity of B, call it B, probably. We had plus ue over root 2, plus u over root 2. And the magnitude, I should probably call them V, I'm muttering to myself here, probably call them V. The magnitude of the velocity of A, which is the speed, is equal to the square root. They're both going to be the same actually, we're going to be squaring them, so we get rid of the negative. So the velocity of A and B are going to be the square root of this guy squared, u squared e squared, u squared e squared over root 2 to be squared, which is 2, plus this guy to be squared, u squared over 2. So that's equal to the square root, same denominator. So we have u squared as common, so I'll factor that out. U squared would leave e squared plus 1. And I have products here, so I can say that's the square root of, well, I'll do it the long way, it's the square root of u squared over the square root of 2, separating them by the square root of e squared plus 1. I know you can do this in a quicker step. So that's why it's going to be equal to u over root 2 by the square root of e squared plus 1. I don't think this tidies up any better, so this is the magnitude of the velocity of A, and that's the same as the magnitude of the velocity B. Now, what is going on here? We have A is going in this direction, B is here. What are we asked in the second part? The angle between them. If E is a half, show the angle of collision is equal to something. So E is equal to a half. Let's just see what we have here. E is a half. So just bring these down. Do my diagram. Okay, let's have a look here. They've collided. We have a negative positive and a positive negative. And these angles are going to be the same, aren't they? Because the tan of A and the tan of B are going to be the same. B is positive, positive. B is over here, and A is in this direction. When we look at the tan of A, it's going to be equal to u over root 2. And that will be divided by this guy or multiplied by the inverse of it, so root 2 over ue. So the tan of A, which is equal to the tan of B, is going to be the u's cancelled, the root 2's cancelled, 1 over e, and e was a half, so 1 over a half is equal to 1 times 2 over 1. So the tan of A is equal to 2, and the tan of B is equal to 2. Tan of B is equal to 2, or 2 over 1. So get the angle in between. The quick way to do it will be the tan, the inverse tan of 2 is equal to 63.435. And multiply that by 2. I'm going to get 126.870 or 87, and 180 will be the angle in between. This one, it's going to be 180 minus 126.87, which is 53.13, but you all know this angle. So the tan of 53.13 is equal to 1.33 repeating, which is equal to 4 over 3. QED. That would be the way I would do it really quickly in an exam. If I had time, I'd go back, maybe do it this way as well, because I know some of you are going to use your trig identities. So if we look at it like this, the tan of A and B being the same, I'll call them both A, and call this theta. So we have the tan of 2A, or 180 minus the tan of 2A, is equal to theta. Sorry, 180 minus 2A is equal to theta, not tan of 2A. So what do we know about 2A? Well, we know the tan of 2A. We know the tan of A. The tan of A is equal to 2. The tan of 2A is equal to twice the tan of A from the tables over 1 minus tan squared A. Twice the tan of A is twice 2, and the tan of A is 2, so tan squared A is 4, 1 minus 4, so this is equal to 4 over minus 3, or minus 4 over 3. So it looks like we're nearly there. We have the tan of 2A. Now, what about if theta is equal to 180 minus 2A? We have A minus B, so we can say that tan theta is equal to tan A, tan 180, minus tan B, minus tan 2A, tan A minus tan B over 1 plus tan A, tan B, 1 plus tan A, which is tan 180, tan B, which is tan 2A, and the zeros help us here, so we have 0 is tan of 180, minus the tan of 2A, well, it's minus 4 over 3 from up here, so we have minus 4 over 3 on top, and on the bottom we're going to have 1 plus this 0 times minus 4 over 3, which is equal to 4 over 3 over 1, which is equal to 4 over 3, and probably that's the way most of you will do it. Both answers will be acceptable, so good luck practicing the 2005. Beware that it could come up in 2022.